Hello, Chantelle. I would like to go through that particular question that we couldn't finish the other day, which is on your textbook, I believe. I think it was question 3 in one of the modeling, one of those modeling questions, right? So we are given an equation x. Now this is the displacement, right? X is the displacement of the air particle, right? Of the air particle that the note C make, right? Remember that's the sound. So, and then we would one of the question, I think it's question B, were to ask us to find, or C, I think, B or C, I forgot. We were to find how many time in 1 second. How many time does the air particle has a velocity of 0 in 1 second? Right, that was the question, something like that. No, not the exact wording, but something like that. So what we did is, okay, well, since we got the displacement formula, we need to differentiate the displacement formula with respect to time to give us the velocity formula, right? So the velocity formula with respect to time is equal to differentiating the displacement with respect to time, which is the same as 2272 A cos bracket 2272 t. Alright, that's a derivative. And we were asked to find how many times does a particle has a velocity of 0. So how I went to tackle that question is, we just change the velocity to 0 and then write down the equation and find out the time, right? When it has a velocity of 0, and it came out to be, I believe it came out to be t equal to 0.00069 and 0.002074 second, right? Second. So, and then we were like, what to do with it? So when I have a think about it, and I finally got it out, which is quite embarrassing. I should have got that on the spot, but if we actually did what you were about to do that day, you were about to plot it, right? You were about to plot the graph. So it's a cosine function is something like that, right? Something like that, right? Now, we know that these 2 points is 0.00069 and 0.002074. And in one of the previous questions, we also found the period, right? The period, right, is using the letter t for it, is equal to 2 pi over 2272, right? 2 pi over b. Which give us, did I jot it down? Oh, I got it. 0.002765 second. So that means it completes 1 period, right? So this particular point here is 0.002765. Right, second. Now, wouldn't it be easier if we just find out the frequency? So how many period in 1 second, right? So the frequency is equal to 1 over t, which can be interchanged as t equal to 1 over f. Same thing, right? But we're looking for frequency at this case. because it says how many times in 1 second. That usually tells you you're looking for frequency, right? So frequency is equal to 1 over 0.002765. Right? So let's plug up the calculator. Do that. We get 0.2765. We get around approximately 361.6 times. Now, the 0.6 here is very crucial, right? So the unit for frequency should be hertz. Yeah, hertz. Don't forget that. So that means there is 361.6 cycles within 1 second. So the graph, this particular period happens, this particular shape happens 361.6 times. Now, why is the 0.6 time matter? It's because we're looking for this particular moment, right? When the velocity, so this is a velocity time graph, when the velocity crosses 0, right? We know in one period, in one whole period, the particle, there's two times the particle has a velocity of 0, right? In one period, there are 2 times that the particle has a velocity of 0. It crosses the x-axis or the t-axis here, right? So in one period, two times there's 2 moments that it has a velocity of 0. So in 361 period, wouldn't that make sense if we just go 361 times 2, right? That would give us 722. All right, so that means the air particle will have a velocity of 0 about 722 times in 1 second, right? Now, the 0.6 comes into play here. Now, 0.6 of a time, you would probably be thinking 0.6 of a period. So 0.6 of a period, let's say, is around here, right? A bit more than a half, right? A bit more than a half. So right here, this is 1 second, right? This is 1 second. Let's say right here it is 1 second. It cuts this particular sine curve, the cosine curve like this. So this is the last period that we're talking about. This is the last period of the air particle velocity. So it comes down to here, which is a velocity of 0. Oops, which is a velocity of 0. And then when it comes to here, 1 second is finished. So that means instead of 722 times, it's actually 722 plus 1 times, right? Because the 722 stops here, right? At this moment, this is 722 times already, right? So this 0.6 gives us one more time that the particle will have a velocity of 0, because it's only half of the thing, right? Now you would say that this is not likely. Then the 1 second will cut here, because 0.6, because the cosine graph is evenly distributed into 4 sectors. So sector 1, sector 2, sector 3. Like if this is 0.5, right? If this is 0.5. This is called the sector 3, sector 4. So these 4 sectors, or these 4 proportions, are even. So 0.6 would probably go a bit more than, go into a bit of the sector 3, but it wouldn't go into sector 4. So it will not approach velocity of 0 again. So instead of twice, it will give us 1 extra time that its velocity is equal to 0. So the answer, I believe, in the textbook, it will be 723 times. So that's why the number, and that's how they come from.